Everyone, so in this video we are going to discuss a matrix problem. Now, if you look at the question, the matrix says that the problem says that you have to input a dimension of the matrix where the m and n has a limitation. It should be uh, between the range of 2 and 10, the dimension, and then you have to input the matrix, and then you have to do a prime replacement, which says that whatever number is there in the matrix, you have to get the next closest prime number of it and then put it there. And then the second part, you have to arrange each row in a descending order. Let's understand it. The user has given here 3 and 3, the matrix of 3 into 3, and then enter the element of the matrix that is taken care. Now, one more thing you have to do here is the matrix is to be input in a one line. So 4, 6, 8, 9, 12, 15, 20, 25, and 27. All the entries of the matrix has to be in one line separated by comma. That means you have to use a string and pull out the things. And then matrix is to be printed. Now you have to create another matrix which is the next prime of the current position. Like let's see, 4. Now 4 is a number, and next prime out of 4 after 4 is 5. So now 4 will be replaced by 5. And 7. Sorry, the number is 6. The next prime is 7, so it will be replaced by 7. Now 8. After 8, 9 comes, 9 is not a prime. 10 comes, 10 is not a prime. 11 comes, 11 is a prime. So this way, every digit will be replaced, every number will be replaced by the next prime of that in the series. And after that, you're just sorting out the row wise in descending or ascending order, rather, to 9 to 9, or descending order. 17, 13, 11, and 11, 7, 5, right. So let's do this. Here it is. Let me go to the main, take it to the main. In the main, we are asking for m and n from user. We are checking the condition that m should not be equals to n. M and n should not be different. They should be same actually. If m is not equals to n, that is an error, invalid, because it has to be a square matrix. And m should be more than 10 and n should also be more than 10. It should not be below 10. I'm sorry, it should be below 10. If it goes below after 10, then it should give invalid output, and then the system program should exit. Then you declare the matrix of whatever the dimension the user has given. Then you're taking the value from the user. Now you're taking it as a string, as I told you. You're taking the input as a string because it has to be taken as with commas. Now you have to use string tokenizer here, so you can pull out, you can put the comma as a delimiter and pull out all the tokens out of it. Now, how will you collect the tokens and store it into matrix? So you'll run a loop for matrix ij in m and n, and you will say that in the ijth position of the matrix, you'll pull out the next token. So it's st.next token because st is the string tokenizer object. And then whatever comes out there, you convert it to integer and store it into matrix. That's the way you're going to do this. So every string token is converted into integer and stored into matrix. Then you have to say, you have to print the matrix. So here we are printing out the matrix. Same way, the running loop ing and printing it out. And now we have to create a matrix, means we have to replace that element of the matrix with the next prime. So we have a function called next prime, where we are sending the number plus 1. We're not sending the current element because we have to, even though the current element happens to be a prime, suppose the content is 3, which happens to be a prime, I don't have to replace it by 3. I have to replace it by the next prime. That means after 4, 4 is not a prime, 5, 5 is a prime by 5. So that's why we are sending by adding 1. So that number itself is not to be sent. You have to add 1 to it to make it next, and then you have to send it to next prime. So the next prime function over here, where we have got next prime here. The next prime function, it's what's doing, you know what is a prime. A prime number is a number which has only 2 factors. So the number matrix element has came here as a NO, and we are just running a loop from 1 till that number and calculating the factor out of it. So this loop runs, the do while loop, till factor doesn't become 2. Okay. And then inside that we are running a for loop to calculate the factors. So if that factor happens to be 2, we just come out of the loop. If that factor doesn't happens to be 2, we are just increasing the value of NO by 1. Okay. Now, for example, user has given, say, 2, right? So it comes over here, it checks the factors of the 2. Now, factors of the 2 uh, is not going to be 2. Let's not take 2, let's take another number, say, so that I get more numbers in the series. So let's take, say, 8, right? So the factors of 8 are not going to be only 2, they are going to be more than 2. So it's going to calculate factors of 2. The factor of 2 are 2, even since we are including 1 also, so 1 is also factor 1, 2, 4, and then 8. So 4 factors. So that's when this condition doesn't satisfy, it doesn't have a 2 factors. So it goes to the else part, increase the value of NO. Now 8 becomes 9. And now we are checking, it comes back to the loop again and we check the factors of 9 now. So factors of 9 now happens to be 1 is a factor of 9, 3 is a factor of 9, 4, 5, 6, 7, 8, and 9 is a factor of 9. That has 3 factors. Again, the factors are not 2. So increase the value of NO by 1, it will make it 10. Now we'll do the factor of 2, which are 1 is a factor of 2. So 2, 5, and 10. 4 factors. Again, factor is not 2, it will increase the value of it by 1. 11. So we'll do the factors of 11 now. 1, then 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11. So now it has got 2 factors. So once it gets 2 factors, it's just going to break out of the loop. And it breaks out of the loop and it sends that number, breaks out of the loop, let me show you, breaks out of the loop and it sends that number back to the place from where it's called. That means that is going to be the next prime. So in our case, 11 is going to be the next prime. So it just takes it back, goes over here. Where did we call it? Here. Here. So it comes back here and gets stored into that array's current position. Replaces that number, whatever is there. So now we got an array with next prime. And now this is the, we are printing that matrix now, and then we have to sort it out also. Now for sorting in descending order, what we're going to do, we are running a loop, and what we're going to do, suppose my matrix is 4, 7, 8, 9, 11, 5. Although this is not a next prime, let me make it a next prime matrix only. So 2, 3 is a prime, so 5, 6, 7 is a prime, then 11 is a prime, then 19 is a prime, and then 17 is a prime, and then 13 is a prime, and then 2, 3, 5, 5 is a prime, and then 6, 7, 7 is a prime, and then another 9. 9 is not a prime. 19 or 17, whatever you want to put. So this is suppose the matrix. Now we have to take every row of a double dimension matrix is again a single dimension matrix, if you can observe over here. Okay, so we have to sort this particular single dimension matrix. So there are 3 single dimension matrix into it. These 3 single dimension matrix I have to sort it in descending order. That's the idea. Okay, so when I say that every row of a double dimension matrix is a single dimension matrix, what I mean by that is, so now what is the address of this single dimension matrix? It's going to be mat 0. Okay, and the jth part will be 0, 1, 2, 3. Of course we know that. And this will be mat 1 and this will be mat 2. So that will be the name of the single dimension matrix. So now what we are going to do, we are sending that particular mat I. Now value of I is 0. So first we'll send mat 0. So this one will go to the function called sort row, where sorting will happen. Let me show you how the sorting is happening. It's a simple sorting technique we would be using here. So where's the sort function? Here, the sort function. I just take the full row as in single dimension array and runs a loop till the length of the row, runs another loop till the length of the row minus 1. This is a bubble sort technique. So if the jth loop, jth value row, jth element of the row is less than j plus 1th, we're just swapping it out. Okay. Since arrays are passed by reference, you need not to return it back. Automatically the changes done by this particular function will happen in the array itself. So it's passing by reference case. So then it comes back and makes already the changes will be made in the function in the array itself. So here one by one you are sending it, right? And then after sending it to the sorting is doing the sorting, and then you are printing it out here. Okay. So let me show you the output of this, and then we'll quickly wind up this video. So here is the code. My next line. I just compile it, and I'm going to run it. Here's my main. Next line. So I give 3 by 3. Let me take the input from the question itself. So question has the input here, some input simple. I'm sorry, and the question means here. Yeah, it has some input. So the input 3 by 3 it has 4, 6, 8, 9, 11. Okay, these are 4, 6, 8, 9, 11, 9, 12, 15, 20, 25, 27, 4, 6, 8. So I have to do it like this 4, 6, 8, 9. After 9, I have 12, 15, 20, 12, 15, 20, and after 20, I have 25, 27, 25, and 27. And now it shows you the original matrix, and this matrix is the next prime. Let's check it. 4, the next prime is 5, correct. 6, the next prime is 7, correct. 8, the next prime is 11. 9, the next prime is 11. 12, the next prime is 13. 15, next prime is 17. 20, next prime is 23. 25, next prime is 29. 27, next prime is 29, correct. Now these are arranged in descending order. 5, 7, 11 is 11, 7, 5. 11, 13, 17 is 17, 13, 11. And 23, 29, 29 is 5. That's it. I hope you would have understood this. Thank you for giving me your time. I'll share the code also in the description if you want to use it. Please practice and comment me. Please like the video if you actually liked it. Thank you. Bye bye.